Today we're taking a look at the DS1302 RTC module. This is a real-time clock module. Once you set the time, it keeps running on its own, even when the Arduino is powered off, because it's powered by a small CR2032 backup battery right on the board. It tracks time, day of the week, and date with automatic leap year compensation all the way through the year 2100. The VCC and GND pins on the module are for power. The other three handle communication. CLK controls the timing of data transfer, DAT sends and receives time and date information, and RST activates the module before each communication session. The module also has a 32.7 kHz crystal. The chip itself consumes less than 1 microwatt in standby mode, so the backup battery will last for years. Connect the module's VCC to 5V, GND to GND, CLK goes to digital pin 6 on the Arduino, DAT to pin 7, and RST to pin 5. You can use other digital pins too, just specify them in the code. Now open the Arduino IDE, go to the library manager, and search for the library called RTC by Makuna. Install it. This is considered the best library for the DS1302. In the code, we include 3-wire and RTC DS1302 from the Makuna library. Then we define the pins and create an RTC object. In the setup function, we call rtc.begin to initialize it, then use rtc.datetime with the date and time macros. These pull the current date and time from your computer at compile time. We pass that into rtc.setDatetime and the clock is set. In the loop function, we call rtc.getDatetime to get the current time, then print the date, time, and day of the week to the serial monitor every second. Upload the firmware, open the serial monitor for a moment, then comment out the set date timeline and upload it again. If you leave this line in, the clock will reset to the compilation time every time the Arduino powers on. Open the serial monitor and you will see the current date and time. Now let's add an LCD1602 with an I2C adapter to display everything nicely. Extend the previous circuit by connecting the LCD display's VCC pin to 5V, GND to GND, SDA to pin A4, and SCL to pin A5. We add two libraries to the code, wire and liquid crystal I2C. We initialize the LCD display with I2C address 0x27. We define a day names array with 3-letter abbreviations for each day, from Sunday to Saturday. There's a small helper function called print 2 digits. It adds a leading 0 if the number is less than 10. In setup, we initialize the LCD, turn on the backlight, and set the time the same way as before. In the loop, we get the current time and format 2 lines on the display. First line, day of the week, then the full date. Second line, the word time is, followed by hours, minutes, seconds. Upload it and you've got yourself a working clock. Now, one important thing to know, the DS1302 can drift by up to 30 seconds per week. It uses an external crystal without temperature compensation, so as the room temperature changes, accuracy gets worse. For learning purposes, that's totally fine. But if you're building something where time really matters, take a look at the DS3231. It has a built-in temperature compensated oscillator and only drifts about 2 seconds per month. It costs a little more and it is absolutely worth it. The full code and wiring diagram are in the description. See you in the next one.